get this. There's this AI model out there, and it's smaller than some of its competitors, but it performs just as well. And get this, it's all thanks to this technique called mixture of experts.
Oh, wow.
Yeah. So that's what we're diving into today.
Yeah.
This whole idea of MOE and how it's like changing the game for large language models, especially as we go further into 2024.
You know, what's fascinating to me about MOE is that it really tackles this core problem we have in AI development, scalability.
Right.
Like, we keep pushing for these, like, bigger, more powerful models.
Yeah.
But the computational cost of, like, training them and running them is just, it's a huge barrier.
Yeah.
And MOE offers this way to build models that are incredibly knowledgeable without needing a supercomputer for, like, every single task.
Okay, so let's break down what MOE actually is.
Yeah.
It's not just like one giant AI brain, right?
Right.
Our notes mention something about experts.
Yeah, so imagine, like, a team of specialized AI agents.
Okay.
Each one is like a master in a specific area. And instead of activating all of these experts for, like, every single input that comes into the model,
Right.
MOE dynamically selects the right expert for the job.
So it's like you have a room full of specialists.
Exactly.
And you just route the question to the person with the most relevant expertise.
That's a great way to put it.
Okay, that makes sense. And our sources mention that this is especially helpful for those really computationally expensive feed-forward networks.
Yes.
Within transformer models.
Exactly. So those FFN layers, they're like the thinking part of the model, right?
Right.
And as the models grow,
Yeah.
they can become so incredibly resource intensive.
Right.
Mo is amazing because it lets us have these models that have tons of experts.
Yeah.
And therefore, like, a wider range of knowledge. But only a small subset of those experts are active at any given time.
Oh, okay.
So it's a way to get all the brains without all the computational strain.
So how does the AI decide which expert to call on? It's not like there's a little directory inside the model.
Right. Well, that's where the gating function comes in.
Okay.
This is kind of like the traffic cop of the MOE system.
Okay.
So it analyzes all of the incoming information.
Right.
And it decides which experts are most likely to give, like, the best output for that given information.
All right, let's unpack this gating function a little bit more.
Sure.
Because research mentioned a couple different types.
Yeah.
There's sparse gating, which sounds pretty self-explanatory.
Yeah. So with sparse gating, only the top few experts that are most relevant to whatever the input is get activated.
Okay.
And that's the most efficient option.
Okay.
But it can lead to some experts being overworked if we're not careful. So it's like, a popular professor's office hours, everyone wants their time.
Everyone's lining up.
Exactly.
And then there's dense gating, which I guess is the opposite.
Yeah, so dense gating activates all the experts for every single input.
Oh, wow.
So you get higher accuracy with that, but at a much greater computational cost. It's like having every specialist in the room weigh in on every question.
Even if their expertise is not really needed.
Exactly.
Okay, so it's a trade-off between being super thorough and being efficient.
Totally.
And then our notes also mention soft gating.
Yeah.
What's that about?
So soft gating is a little bit more nuanced.
Right.
It blends the outputs of multiple experts.
Okay.
Sort of like a weighted average, if you will.
Okay.
So think of it as a panel of experts where each member's opinion is taken into account, but some voices carry more weight than others.
Okay, that's interesting.
Yeah.
Now, some of the examples of how this gating works in practice are just fascinating.
Oh, yeah.
I mean, imagine a model where the experts themselves choose which pieces of input to process.
That's pretty cool.
It's amazing. Our research calls that expert choice gating.
So that's a really clever way to avoid some of those load balancing issues that we talked about.
Yeah.
There are also some approaches where they use what's called non-trainable gating.
Okay.
And so the expert selection is determined beforehand.
Okay.
Maybe through a hashing function or something super efficient.
Right.
But it might lack that flexibility of some of the other methods.
It's amazing how much variety there is in these approaches.
Yeah.
And it seems like MOE can be applied in really creative ways.
Totally.
For instance, our sources highlighted how multilingual models can use gating to route different languages to specific experts.
Oh, that's a good one.
Yeah, it's like having dedicated translation teams.
Yeah, totally.
In the AI system.
Exactly.
Each specializing in a particular language pair.
Exactly.
Okay, so we've got these expert teams.
Yeah.
We have this gating function kind of directing the traffic between them.
Mm-hmm.
But what about the experts themselves?
Right.
What are they made of?
So Most commonly, the experts are feed-forward networks.
Okay.
That same type of layer that can get so computationally expensive
Right.
in larger models.
Yeah.
But interestingly, the research suggests that these FFN layers, they're where a lot of the sparsity lies.
Okay.
Meaning that a lot of processing power is wasted on, like, irrelevant data.
So by breaking down those layers into more specialized experts,
Exactly.
we can potentially make them much more efficient.
That's the idea.
Okay, but the research also mentioned that MOE can be applied to other parts of the model.
Oh, absolutely.
Not just FFN layers, right?
Yeah, it can be used with other network types, like attention mechanisms.
Okay.
So imagine having expert teams for both, thinking and paying attention within the AI system.
Right.
Really opens up a lot of possibilities for even more sophisticated models.
Okay, so we have all these experts.
Yeah.
We have all these ways to activate them.
Right.
But how do you even decide how many experts to have or how big each expert should be?
Right. So those are some of the key questions that researchers are really grappling with. The number of experts, the size of each expert, how often MOE layers are used.
Right.
Those are all hyperparameters that we have to very carefully tune.
So it's not just about having more experts.
Yeah.
It's about having the right configuration
Yeah, you got
to
it.
the task at hand.
Yeah.
Now, I'm also curious about this placement frequency our notes mentioned.
Oh, yeah. So that refers to how often we actually replace standard FFN layers with MOE layers within the model.
Okay.
So it directly impacts the overall model size and computational overhead.
So designing a MOE model is about finding the right balance.
It is, yeah.
The right number of experts, the right type of gating function, the right placement frequency. It's like putting a puzzle together.
That is a great analogy.
There's not just one solution.
Nope.
And the optimal MOE design depends on the task, the available computational resources, and the goals.
You got it.
And speaking of performance, how do we even train these MOE models? Do we just throw a bunch of data at them and hope for the best?
Not quite, haha. So there are different training schemes,
Okay.
each with its own advantages and disadvantages.
Right.
One approach that people use is called dense to sparse,
Okay.
where you start by training a really dense model.
Okay.
So all the experts are active.
Uh-huh.
And then you gradually transition to a more sparse MOE setup for efficiency.
So it's like you start with a generalist,
Yes.
and then you kind of like nurture them over time
Exactly.
into becoming a team of specialists.
Exactly.
Yeah.
And we also have sparse to dense,
Okay.
where the model is trained in a sparse configuration,
Right.
but then it might switch to a dense configuration for deployment
Okay.
on specific hardware.
Oh.
And then there's this idea of merging experts,
Okay.
where you actually combine multiple pre-trained expert models
Oh, wow.
into like a unified MOE structure.
So it's like assembling this all-star
Yes,
team
exactly.
from different leagues.
Love it.
Okay, so we've covered, I think, the basics of how MOE works.
Yeah.
The different types of gating functions, the structure of the experts,
Mhm.
the hyperparameters involved, even how these models are trained.
Yeah,
But why should anyone care?
right.
What's the real-world impact of all this?
Yeah. So that's where things get really exciting.
Okay.
MOE is already making waves in the world of AI.
Yeah.
It's allowing us to build these smaller, more efficient models without sacrificing performance.
So it's not just a theoretical concept.
No.
It's actually being applied to real-world problems.
Absolutely.
Like
Yeah.
what?
So, for example, there's a model called Mixtral 8x7b,
Okay.
and it uses MOE.
Okay.
And it performs just as well as models like Llama 270b,
Huh.
even though it's significantly smaller.
Wow.
That's a huge win for efficiency.
It's like David and Goliath
Haha. I like.
in the AI world.
Yeah, exactly.
Our research also mentioned a couple other examples.
Oh, yeah.
DeepSeek MOE 16b
Yeah.
and Qwen 1.5 MOE.
Yes, those are other models that show the power of MOE to achieve comparable performance to these larger, more resource-intensive models.
So the trend is clear.
The trend is clear.
MOE is allowing us to build like leaner, meaner AI models.
Exactly.
Amazing. But even with these advancements,
Yeah.
I imagine there are still some limitations
Of course.
to this approach.
Yeah. So one of the ongoing challenges is load balancing.
Okay.
We need to make sure that all the experts are being utilized effectively,
Right.
that no single expert becomes a bottleneck.
Right. And scalability.
No, of course, scalability is a big one. As these models get bigger,
Yeah.
we're going to need incredibly efficient distributed training techniques.
And I imagine interpretability is also a major concern,
Huge concern.
especially as these models become more complex.
It's absolutely right. Understanding why certain experts are chosen for a task is just crucial for building trust in these models and for improving them further.
Okay, so we've got this incredible technique for building smarter, more efficient AI.
Yeah.
It's already being applied in the real world, but there's still challenges.
That's research.
Yeah, it's like we've taken a peek under the hood of this super powerful engine.
Yeah.
We can see the gears turning.
Yeah.
But we're still figuring out how to optimize the performance.
I love that analogy.
And the potential is undeniable.
It is.
Imagine a future where MOE allows us to build AI that learns like humans do.
That would be amazing.
By assembling and refining knowledge from all these specialized areas.
Yeah, it's a really exciting field to be watching right now.
That's MOE in a nutshell.
It is.
This revolutionary technique that's changing the landscape of AI.
Totally.
But this is just the beginning of our deep dive.
That's right.
In part 2, we're going to explore some real-world examples of how MOE is being used today.
I'm excited for that.
Stay tuned.
Welcome back. Last time we kind of laid the groundwork, explained what mixture of experts is and how it works. Yeah. So now let's kind of shift gears a little bit and dive into the real world impact of this technology.
Yeah, I'm really curious to see how MOE is being applied across different fields.
Yeah.
Our notes mentioned a bunch of interesting examples, starting with natural language processing.
Oh, yeah. That's a great place to start.
Okay.
MOE's it's revolutionizing how we approach things like machine translation, chatbot development, even content creation.
So the AI tools that we use every day could be getting a boost from MOE behind the scenes.
Absolutely, yeah. So take machine translation, for example.
Yeah.
Traditional models often struggle to translate between languages with very different grammatical structures.
Right.
But with MOE, you can have experts specializing in specific language pairs, which leads to much more accurate and natural-sounding translations.
So it's like having this team of expert translators, each fluent in a particular combination of languages.
That's a great way to put it.
No more awkward robotic translation.
Exactly, yeah.
And MOE is also being used to power those increasingly sophisticated chatbots that can understand and respond to complex requests.
Right, they can handle customer service inquiries.
Oh, wow.
Offer technical support.
Okay.
Even engage in casual conversation.
That's a huge leap forward from those basic bots that could barely understand a simple command.
Right. Exactly.
Now we're talking about AI that actually feels intelligent and responsive.
Yeah, it's getting there.
And it's not just about understanding and responding to language.
Right.
MOE's also making waves in AI-powered content creation.
That's right.
We're talking about writing stories, composing music, even generating art.
Yeah.
Hold on. So that novel I just read, or that catchy song I heard on the radio, could have been created by an AI?
It's possible.
Powered by MOE.
Yeah, entirely possible. The lines are getting blurrier and blurrier.
It's mind-blowing.
Yeah.
But it's not just natural language processing where we're seeing these advancements.
Right.
Our research highlighted another field, computer vision.
Right. So MOE is being applied to image recognition, object detection, even self-driving cars.
Wow.
It's changing how AI interacts with the visual world.
So things like facial recognition software or those AI-powered security cameras could be using MOE to improve accuracy.
Absolutely.
Wow.
Imagine a security system that can not only detect movement, but it can also distinguish between a harmless animal and a potential intruder.
Okay.
That level of nuance is becoming possible with MOE.
So it's like having a team of expert detectives.
Totally.
Each trained to spot specific details.
Exactly.
No more false alarms or missed threats.
Hopefully not. We'll see.
And in self-driving cars, MOE is being explored as a way to handle those complex split-second decisions needed to navigate busy roads.
It's a tough one.
So MOE could be the key to unlocking the full potential of self-driving cars.
Potentially, yeah.
That's both exciting and a little bit unnerving. Okay, so we've got natural language processing and computer vision.
Yeah.
But our sources hinted that MOE is being used in even more fields.
It is, yeah.
Where else is this technology making an impact?
So the healthcare industry is one area where MOE is showing a lot of promise.
Okay.
So imagine AI systems that can diagnose diseases.
Right.
Predict patient outcomes.
Wow.
And even personalized treatment plans.
So MOE could be a game changer for doctors.
Potentially. Yeah.
Helping them make more informed decisions and potentially saving lives.
That's the hope.
And it's not just about diagnosis.
Right.
MOE can also be used to analyze medical images,
Okay.
like X-rays or CT scans,
Right.
potentially speeding up diagnosis and improving accuracy.
It's like having a team of specialized radiologists
Right.
working alongside human doctors, offering their expertise
Exactly.
and insights.
Yeah.
And let's not forget the financial entry.
Yeah, finance is a big one.
MOE is being used to build models that can detect fraudulent transactions.
Assess risks,
Yeah.
even make investment recommendations.
It's getting there.
So MOE could help us manage our money more effectively,
Right.
protect us from financial scams.
Potentially. Yeah.
Sign me up.
That's a good one.
It's an exciting time for those working at the intersection of finance and AI.
Absolutely.
The potential for innovation is huge.
Yeah, I think so.
These are just a few examples, but it seems like MOE is truly a versatile tool.
It really is.
It's popping up everywhere.
It is, yeah.
But with all this potential, it's important to remember that MOE is still a relatively new technology.
Yeah.
There must be challenges
Of course.
and limitations that researchers are grappling with.
Right. One of the biggest is ensuring that these models are fair, unbiased, and transparent.
We've seen some high-profile cases
Yeah.
where AI systems ended up perpetuating existing biases
Yeah.
or making unfair decisions.
It happens.
We need to be careful not to repeat those mistakes.
Absolutely. Yeah. As MOE models become more complex.
Right.
It's crucial to make sure that they're not amplifying like societal biases or
Yeah.
making decisions that could negatively impact people
Right.
or communities.
And I imagine transparency is a big issue, too.
Oh, huge. Yeah.
If these models are making important decisions in areas like healthcare or finance,
Yeah.
we need to understand how they're arriving at those decisions.
That's right. Yeah. That lack of transparency can erode trust
Right.
and hinder the adoption of MOE in critical applications.
Right.
So researchers are working on techniques to make these models more interpretable
Okay.
so we can understand like the reasoning behind their decisions.
So it's not just about building powerful AI. It's
Yeah.
about building AI that we can trust and understand.
Exactly.
That makes sense.
As we continue to explore the potential of MOE,
Right.
we need to do so responsibly with a focus on fairness, accountability, transparency.
Okay. This has been a fascinating exploration
Yeah.
of the real-world applications of MOE. It's clear that this technology has the potential to revolutionize many industries.
It does.
And we're only just getting started.
We are.
In the final part of our deep dive,
Right?
we'll look ahead to the future of MO
Okay.
and explore some of the potential breakthroughs and challenges that lie ahead.
Exciting times.
Stay tuned. Welcome back to our deep dive into Mixture of Experts. We've covered a lot of ground, from the technical details of how MOE works to its real-world impact
Yeah.
across all these different fields.
It's been pretty wild.
So now it's time to gaze into our crystal ball a little bit
Okay.
and explore what the future might hold for this,
Yeah.
kind of game-changing technology.
It's always exciting to like speculate about the future, right?
Yeah.
Especially in a field that moves as fast as AI.
Yeah,
With MOE, it feels like the possibilities are just endless.
yeah. And our research hinted at some, like, really exciting potential breakthroughs on the horizon. So where do you see the most promising developments happening?
Well, one area that's generating a lot of buzz is the development of even more sophisticated gating functions.
Okay, and remember, the gating function is that traffic cop of no.
Yep.
It decides which experts get activated for a given task.
Exactly.
And we talked about those different types of gating functions.
Yeah.
Sparse, dense, soft gating.
Right.
So
Yeah.
what's changing in this area?
So researchers are exploring new ways to make those gating functions more like dynamic
Okay.
and adaptable. So imagine like a gating function
Yeah.
that can learn and evolve over time.
Oh, wow.
So it gets even better at selecting the most relevant experts for a given situation.
So it's not just about choosing from a fixed set of experts.
Exactly.
The system is learning how to optimize that selection process.
You got it.
That's amazing.
And that could lead to like significant improvements in accuracy and efficiency.
Yeah. That makes sense. Are there other areas where you see potential for breakthroughs?
Well, another exciting avenue is the development of what are called hybrid MOE models.
Oh.
These combine different types of experts.
Okay.
So imagine a model that has experts specializing in, say, language,
Okay.
vision, and reasoning.
Right.
This could lead to AI systems that are much more versatile and adaptable.
That's fascinating. It's like you're creating an AI system that can seamlessly integrate all these different modes of intelligence.
Yes, exactly.
Almost like a human brain.
That's a great way to put it.
And this opens up all these possibilities for AI applications that require, a combination of skills.
Totally.
Things like robotics, personalized education, even creative problem solving.
Yeah, absolutely.
So it sounds like we're moving towards AI systems that are not only more intelligent,
Yeah.
but also like more well-rounded.
More human-like in a way.
But of course, with every leap forward, there are challenges.
Always.
So what are some hurdles that researchers need to overcome as MOE evolves?
Well, scalability is still a big one.
Okay.
As these models grow even larger and more complex, we need to find efficient ways to train them and deploy them. Right. And this might require, new hardware architectures, more sophisticated software tools. Right. Even entirely new approaches to AI development.
It's like we're building this rocket ship to explore uncharted territory.
Yeah, I like that.
But we need to make sure the engines are powerful enough. Right. And the fuel tanks are big enough to get us there.
I love that analogy.
Another challenge is ensuring that these advanced AI systems remain aligned with human values and goals.
That's huge, right?
Yeah. As we delegate more and more tasks to AI, we got to be careful that these systems are working with us, not against us.
Absolutely. It's not just about building powerful AI. It's about building AI that serves humanity.
Right.
That contributes to a better future for everyone.
And as MOE models become more, integrated into our lives, we need to find ways to make them more transparent.
Of course.
And accountable.
Yeah. So if an AI system makes a decision that impacts someone's life, we need to be able to understand how and why.
Exactly. It's about building trust.
Yeah.
And making sure that these systems are used ethically and responsibly.
Totally.
That's a tough one.
It is. It's a complex challenge.
Yeah.
But one that we absolutely have to address as we move forward.
Okay. So the future of MOE.
Yeah.
Full of incredible promise.
Absolutely.
But also, some daunting challenges.
Of course.
It's a really fascinating time to be, witnessing this technological revolution unfold.
It is, yeah. And it's only just the beginning, right?
Yeah.
As researchers continue to innovate and collaborate, we can expect, even more groundbreaking discoveries and applications.
Yeah.
In the years to come, who knows what the world will look like when AI systems powered by MOE become just like a normal part of our lives.
It's an exciting thought and honestly a little bit mind-boggling.
It is, yeah.
Well, thanks for joining us on this deep dive into Mixture of Experts.
It's been a pleasure.
We hope you've gained a deeper understanding of this, transformative technology and all the potential it holds.
I hope so, too.
And that's a wrap for today. We'll see you next time for another deep dive into the world of cutting-edge knowledge and innovation.